Hello friends, welcome to Sciacademy. How are you? Hope you all are good and healthy. Now I am going to discuss about a new topic, that is Coulomb's law. This is very important development in the theory of electromagnetism. So let's start. Coulomb's law, also known as Coulomb's inverse square law, is an experimentally based physics laws that quantifies the amount of force between two stationary electrically charged particles. The electric force between charged particles at rest is called electrostatic force or Coulomb force. The law states that the magnitude of the electrostatic force of attraction or repulsion between two point charges is directly proportional to the product of the magnitude of charges and it is also inversely proportional to the square of the distance between the two point charges. Combining these two, we can write it as the the two force between the two point charges on Q2 and inversely proportional to the distance square. Now this force becomes equal to K into Q1 Q2 divided by R square, where K is the Coulomb's constant which value is equal to 8.988 into 10 to the power 9 meter square per Coulomb square, where Q1 Q2 are 2 point charges. The force F is along the straight line joining these 2 point charges. If the charges have the same sign, this electrostatic force between them is repulsive in nature, and if they have opposite charges, they will attract to each other. Coulomb's law in vector form states that the electrostatic force F1 experienced by charge Q1 at position R1 in the close vicinity of another charge Q2 at position R2 in vacuum in vacuum in vacuum is equal to F1 is equal to F1 is equal to Q1 Q2 4 pi epsilon naught into R1 vector minus R2 vector divided by modulus of R1 vector minus R2 vector का whole cube. That is equal to Q1 Q2 divided by 4 pi epsilon naught R1 2 divided by R1 2 square. Here we have taken R1 2 vector is equal to R1 vector minus R2 vector. The vectorial distance between the charges where we have taken K is equal to 1 by 4 pi epsilon naught for vacuum. If the system is in medium, then K will be equal to 1 by 4 pi epsilon for medium. Where epsilon naught is equal to 1 for vacuum or air. Therefore, epsilon divided by epsilon naught is equal to epsilon r, where epsilon r is known as relative electrostatic permittivity. Since electrical force between two point charges is a two-body interaction, so it is independent of presence or absence of other charges, and so the principle of superposition is applied. That is, if force on a charged particle due to number of point charges is the resultant of force due to individual point charges, then it can be written as F1 is equal to F12 plus F13 plus F14 plus that and so on. In terms of vector form, this can be written as for force on a small charge q at position r due to indiscrete charges in volume V. F is equal to Q by 4 pi epsilon naught summation I is equal to 1 to total indiscrete charges Qi into R minus R I divided by moduli of R minus R I whole cube, that is equal to Q by 4 pi epsilon naught into summation I is equal to 1 to n Qi Ri divided by Ri modulus of Ri whole square, where Qi and Ri are the magnitude and position of the ith charge respectively, and Ri is a unit vector in the direction of R minus I, that is a vector pointing from charge Qi to Q. Since Coulomb's law is a inverse square law, it is analogous to the Isaac Newton's inverse square law of gravitation So we will discuss the similarity and differences between these two laws, Coulomb's law and gravitation's law. First, Coulomb's law depends on the nature of the particles, that is, it may be attractive when the particles are of opposite nature and repulsive when particles are having the same nature charges. But in case of gravitation, it is always attractive. Second, since gravitational force is written as F is equal to G into M1 M2 by R square, if electric force is always greater than the gravitational force, this is why when both Fe and Fg are present, we generally neglect Fg. Electric force depends on the nature of medium between the charges, while gravitational force doesn't depend. Fourth, the force is an action-reaction pair, that is, the force which one charge exerts on the other is equal and opposite to the force which the other charge exerts on the first. The force is conservative. Work done in moving a point charge once around a closed path under the action of Coulomb's force is zero, that is, electrostatic force. Fe is conservative in nature. While gravitational force is not conservative. Now there are some limitations in case of Coulomb's law. Which is the charges must have a spherically symmetric distribution, that is, in applying to the case of extended bodies of finite size, the whole charge of a body to be concentrated at its center, as this is true only for a spherical charged body, and that too for external point. Second, the charges must not overlap. that is they must be distinct charges. The charges must be stationary with respect to each other. The equilibrium of a charged particle under the action of Coulombian force alone can never be stable. And this is called as Earnshaw theorem. Friends, this is for now. If you like this lecture, please share it with your friends so that they can also be get benefited, and like the videos and subscribe the channel, and please press the bell icon to get notification on time. Thank you friends, stay tuned.